The recent discovery made by scientists in the heart of our own Milky Way galaxy is one of those rare moments in scientific history that will be remembered for years to come. This discovery is groundbreaking, not simply because it reveals something new, but because it challenges long-established theories and opens the door to a realm of possibilities we never thought possible. For astronomers, physicists, and space enthusiasts alike, it represents a dramatic turning point, a moment when we realize just how much we still have to learn about our galaxy, and indeed, the universe itself. What makes this discovery so remarkable? How does it fit into the vast and complex puzzle that is our understanding of space? And most importantly, what does it mean for our future? To understand the significance of this discovery, we must first appreciate the sheer scale and complexity of the Milky Way itself. Our galaxy, which contains hundreds of billions of stars, each with its own set of planets, moons, and other celestial bodies, has long been a focal point of astronomical research. We've spent decades mapping its stars, studying its spiral arms, and even theorizing about the invisible matter, dark matter, that makes up the majority of its mass. Yet, for all the knowledge we've accumulated, there is still so much we don't understand. For example, we know that the Milky Way is home to a supermassive black hole at its center, but even that poses more questions than answers. The truth is, for as much as we think we know, the Milky Way is still largely a mystery. This brings us to the discovery itself. Recently, a team of scientists utilizing advanced technology and groundbreaking methods of observation uncovered something extraordinary in the Milky Way. It wasn't a new star, nor was it another exoplanet orbiting a distant star. No, this discovery was far more perplexing and intriguing. It revolves around an anomaly, a phenomenon within our galaxy that has never been observed before, and one that challenges much of what we thought we knew about the structure and behavior of galaxies. Imagine, if you will, that we've been living in a world where we believe the rules of space are well established, where the laws of gravity, dark matter, and stellar evolution are all neatly understood. And then, unexpectedly, we discover something that throws all of that into disarray. That's exactly what happened when scientists detected a phenomenon that seemed impossible according to our current models. It's as if the galaxy had revealed a hidden facet, one that defies the very laws we thought governed it. The question now is, what exactly did they find, and why does it matter? At the heart of this discovery is an unexpected shift in how we understand the forces that govern the Milky Way. The team of astronomers, using the latest advancements in telescope technology and data processing, discovered an unusual gravitational anomaly in a previously unexplored region of space. This anomaly, though subtle, was powerful enough to be detected by the most sensitive instruments available. But what made this finding so groundbreaking wasn't just the anomaly itself, it was the fact that it didn't align with any of the predictions made by our existing models of galactic formation and behavior. For decades, scientists have assumed that galaxies like the Milky Way operate in a relatively predictable way. The stars within the galaxy are mostly organized in spiral arms, the gravitational forces are balanced, and dark matter plays a crucial role in maintaining the galaxy's structure. But this new finding suggests that something more complex is at play, something that we haven't accounted for. This discovery is not just an isolated event, it is a clue to a much larger mystery about the true nature of the Milky Way. It forces us to reconsider everything we thought we knew about the galaxy's formation, its internal mechanics, and its evolution over time. But what exactly is this anomaly? While the scientists are still working to fully understand the implications of their discovery, early findings suggest that it involves a previously unknown type of gravitational disturbance within the galaxy. The anomaly is subtle but powerful, and its impact is far-reaching. It could be the key to understanding some of the most fundamental questions in astrophysics, questions about the nature of gravity, the role of dark matter, and the very forces that govern the structure of galaxies. Some researchers even speculate that this could be a sign of something entirely new, a force or phenomenon we've never observed before, one that exists beyond the realm of our current understanding. To fully appreciate the significance of this discovery, we need to understand the context in which it was made. The tools that enabled scientists to uncover this anomaly represent the pinnacle of human ingenuity in space exploration. The discovery was made possible by advancements in gravitational wave detection, radio telescopes, and the latest space observatories, all of which allowed scientists to observe the Milky Way in greater detail than ever before. These technologies, combined with powerful data analysis methods, enabled researchers to detect the faintest gravitational ripples in space, ripples caused by the movement of massive objects within the galaxy. This is not the first time that scientists have detected anomalies in space. Throughout the history of astronomy, we've seen discoveries that have forced us to revise our understanding of the universe. For example, the discovery of cosmic microwave background radiation led to the development of the Big Bang theory, and the detection of exoplanets has reshaped our ideas about the potential for life beyond Earth. But what makes this new discovery so unique is its potential to unlock a whole new area of research. The anomaly detected within the Milky Way could be a key that opens doors to questions we've never thought to ask, questions that could radically change our understanding of the universe. The implications of this discovery are far-reaching. If the anomaly turns out to be what scientists suspect it is, it could have profound consequences for our understanding of the fundamental forces of nature. It could force us to rethink the role of dark matter in shaping the galaxy and challenge our current models of galactic evolution. It could even provide new insights into the mysteries of black holes, wormholes, and the very nature of space-time itself. And perhaps most intriguingly, it could provide us with clues about the possibility of life beyond Earth, questions that have fascinated humanity for centuries but have remained elusive. As the scientific community begins to explore the implications of this groundbreaking discovery, one thing is certain: our understanding of the Milky Way is about to be rewritten. What was once thought to be a relatively simple galaxy composed of stars and dark matter has revealed itself to be far more complex and enigmatic than we could have ever imagined. And as we continue to explore the universe, this discovery may be just the beginning of a new era in space exploration, one where the rules of the cosmos are no longer as fixed as we once believed. The Milky Way, our home galaxy, is a vast and awe-inspiring system of stars, planets, and cosmic phenomena. Spanning over 100,000 light-years across, the Milky Way is one of the billions of galaxies scattered across the universe. Yet, it is our home, our window into the deep expanse of space. To truly appreciate the magnitude of the recent discovery, it's important to understand the scale, structure, and complexity of our galaxy, which, despite being home to billions of stars and an array of mysteries, still holds secrets we are only just beginning to uncover. At the core of the Milky Way lies a supermassive black hole known as Sagittarius A, whose mass is equivalent to millions of times that of our Sun. This black hole is surrounded by a dense, gravitationally bound mass of stars, gas, and dust, and is thought to play a crucial role in the formation and evolution of the galaxy. But even with this formidable center, the Milky Way is not a uniform system. Instead, it is a sprawling, dynamic collection of interwoven components that we are still striving to understand. The galaxy's overall structure is that of a barred spiral with a central bulge, spiral arms, and a large disk that extends outward in all directions. The spiral arms, which contain a majority of the galaxy's stars, gas, and dust, are home to many of the most well-known features of our galaxy, including star-forming regions, nebulae, and a wide variety of stellar types. These arms are also where most of the Milky Way's stars, like our Sun, reside. The disk in which we find the spiral arms is a vast plain of stars, dust, and gas that gradually thins as it stretches farther from the galactic center. The halo of the galaxy, a nearly spherical region surrounding the disk, contains older stars, globular clusters, and a significant amount of dark matter. In fact, Dark matter is thought to make up around 85% of the total mass of the galaxy. Though we cannot directly observe it, it remains one of the greatest mysteries of modern astrophysics. The Milky Way's size is difficult to fathom. To put it in perspective, if our galaxy were to be scaled down to the size of a typical dinner plate, the solar system would be just a tiny speck on the edge. The stars we see in the night sky are only a fraction of the total stellar population in the Milky Way. An estimated 100 to 400 billion stars reside within the galaxy. Our own sun is situated in one of the outer arms of the galaxy, approximately 27,000 light-years from the galactic center where it orbits the black hole. Though this may sound like an incredibly vast distance in the grand scale of the Milky Way, it's relatively close. The sun takes about 225 million years to complete one orbit around the galaxy's center, a journey we refer to as the galactic year. While the Milky Way's structure is well known, much of the galaxy's content remains elusive. The sheer number of stars, the complex interactions of gravitational forces, and the ongoing processes of star formation and death all contribute to a dynamic system that's constantly changing. Some stars are born from vast clouds of gas and dust, while others die in dramatic explosions known as supernovae. These explosive deaths create black holes, neutron stars, and sometimes even trigger the formation of new stars from the ejected material. The cycle of birth and death is what sustains the Milky Way, creating a dynamic environment in which new phenomena continually emerge. One of the key aspects of the Milky Way that fascinates astronomers is its hidden components. The dark matter that envelops our galaxy is invisible and detectable only through its gravitational effects on the visible matter around it. Scientists believe that dark matter plays an essential role in holding the galaxy together, preventing it from flying apart despite the enormous speeds at which its stars orbit the galactic center. This invisible mass is also thought to be responsible for the galactic rotation curves we observe, which reveal that the outer regions of the galaxy rotate much faster than would be expected if only visible matter were present. But it's not just the invisible matter that captivates researchers. The discovery of the Milky Way's many satellite galaxies, small galaxies that orbit our larger one, has also provided valuable insights into its formation. Some of these satellite galaxies are in the process of being consumed by the Milky Way, their stars and gas drawn into our galaxy's gravitational pull, enriching the galactic disk and bulge. This process of galactic cannibalism is thought to have been a crucial part of the Milky Way's evolution, leading to its current shape and structure. The exploration of the Milky Way is not just about understanding the structure and dynamics of our galaxy, however. It's also about understanding our place within it. The solar system, with its 8 planets, including Earth, is located in the Orion arm of the galaxy, one of the Milky Way's spiral arms. Earth itself is situated about 2/3 of the way from the galactic center, making our solar system a relatively peaceful and stable part of the galaxy. Yet, despite this stability, the Milky Way is not as serene as it might seem. There are active regions within the galaxy where stars are being born in massive clouds of gas and dust, and there are other areas where stars are nearing the end of their lives, collapsing into white dwarfs, neutron stars, or black holes. The Milky Way's sheer scale and complexity make it a perfect place to study the processes that govern galaxies, star formation, and the evolution of the universe itself. But even as we gather more and more information about our galaxy, there are still vast regions that remain unexplored. The discovery of new, unusual phenomena within the Milky Way, such as the recent groundbreaking find, reminds us just how much we still have to learn. Our understanding of the galaxy is far from complete, and each new discovery pushes the boundaries of our knowledge, revealing that the more we know, the more there is to learn. Perhaps one of the most exciting aspects of studying the Milky Way is the fact that it serves as a kind of cosmic laboratory, where we can observe the life cycle of stars, the influence of dark matter, and the effects of cosmic events in real time. In many ways, the Milky Way is not just our home. It's a mirror that reflects the larger processes of the universe. By studying it, we gain insights into how other galaxies might evolve, how stars live and die, and how the fundamental forces of nature shape the cosmos. The Milky Way is, in essence, a living, breathing entity, constantly changing, constantly evolving, and constantly surprising us with new revelations. The recent discovery within the Milky Way serves as a reminder of just how much we still don't know about our galaxy. For all of our technological advancements, for all the decades of research and observation, the Milky Way remains a place of mystery and discovery. It's a reminder that space is not just a void to be filled with knowledge, but a living, dynamic entity that holds secrets yet to be uncovered. As we continue to peer deeper into the galaxy, we will undoubtedly find more strange and fascinating phenomena that will further our understanding of the universe. The Milky Way is a galaxy of endless possibility, and our journey of exploration has only just begun. The quest to understand the Milky Way has been a long and arduous journey, one that spans centuries of human curiosity, technological advancements, and revolutionary discoveries. From the first glimpses of the stars to today's cutting-edge observatories and space missions, our understanding of our galaxy has evolved dramatically. Each new discovery builds on the knowledge gained before, and each step forward unravels yet another layer of the cosmic mystery that is the Milky Way. This chapter will explore the history of galactic discoveries, from ancient astronomy to modern space science, and the key milestones that have shaped our current understanding of the Milky Way. The ancient view of the stars. Humanity's relationship with the stars dates back to the dawn of civilization. The night sky has always fascinated and inspired people, and ancient cultures around the world developed rich mythologies and stories based on the constellations. Early astronomers, using only their naked eyes and primitive tools, observed the movements of the stars and planets, creating calendars, navigation systems, and religious frameworks based on their observations. The ancient Greeks, for example, gave names to many of the stars and began to categorize them, laying the groundwork for what would later become modern astronomy. However, the concept of a galaxy was not yet understood. The idea that the Milky Way was a collection of stars rather than a mysterious band of light was far beyond the reach of early astronomers. The Milky Way itself was seen as a celestial river or bridge, and its true nature remained a mystery for millennia. The Renaissance and the birth of modern astronomy. The real turning point came in the early 17th century, when the invention of the telescope revolutionized our understanding of the universe. Galileo Galilei, often called the father of modern astronomy, used a rudimentary telescope to peer into the night sky, and in 1610, he made a groundbreaking discovery. The Milky Way was not a mist or cloud, but rather a collection of stars. He observed the band of light stretching across the sky and concluded that it was made up of countless individual stars packed closely together. This insight was one of the first steps in understanding the true nature of our galaxy. Later astronomers such as Johannes Kepler and Isaac Newton built on Galileo's discoveries by formulating laws of planetary motion and universal gravitation, respectively. These theories would become the foundation of modern astronomy and astrophysics. The work of Kepler and Newton also provided a framework for understanding the motion of stars within galaxies, laying the groundwork for future research into the structure of the Milky Way. The 19th century. Expanding our horizons. As the 19th century unfolded, so too did our understanding of the cosmos. Astronomers began to focus more on the structure of our galaxy, using better telescopes and more sophisticated methods of observation. One of the key figures in this era was William Herschel, who, in the 1780s, made the first attempts to map the Milky Way. Herschel's work was instrumental in showing that the Milky Way was a vast disk-like structure with a central bulge. Using star counts and other methods, he estimated the size of the galaxy and its overall shape, although his models were far from perfect. During the 19th century, astronomers also began to study nebulae, clouds of gas and dust in space. Some of these nebulae were later found to be star-forming regions within the Milky Way, although it was not yet clear that the galaxy itself was made up of billions of stars. The discovery of these nebulae and the observation of stellar spectra, which revealed the chemical composition of stars, added further layers to our understanding of the galaxy. Despite the progress made in the 19th century, the true size and scale of the Milky Way remained unclear. Astronomers could only observe a small portion of the sky, and many still believed that the universe was much smaller than it actually is. It wasn't until the early 20th century that our view of the galaxy would be radically transformed. The early 20th century, a paradigm shift. The early 20th century marked a critical moment in our understanding of the Milky Way. In 1917, the astronomer Harlow Shapley made a landmark discovery that would forever change how we viewed the galaxy. Shapley, using observations of globular clusters, groups of stars tightly bound by gravity, estimated the size of the Milky Way and determined that the Sun was not at the center of the galaxy, as many had previously assumed, but rather on the outskirts. This was a shocking revelation, as it suggested that the Milky Way was far larger than anyone had imagined. Around the same time, Edwin Hubble, one of the most influential figures in modern astronomy, made another groundbreaking discovery. Through his observations of distant galaxies, Hubble was able to demonstrate that the universe was much larger than just the Milky Way. He found that galaxies were not stationary but were moving away from each other, which led to the formulation of Hubble's law. This discovery provided strong evidence for the expansion of the universe and revolutionized our understanding of the cosmos. In the 1920s, the debate over whether the Milky Way was the only galaxy in existence was finally settled. Until then, some astronomers had believed that the Milky Way was the entire universe, with other nebulae being mere clouds of gas and dust within it. However, the work of Hubble and others demonstrated that many of these nebulae were actually separate galaxies, vastly distant from our own. This realization marked the beginning of modern cosmology, forever changing our understanding of both the Milky Way and the universe as a whole. Mid-20th century, mapping the Milky Way. The mid-20th century saw significant advancements in both observational techniques and theoretical models. As radio telescopes and other instruments advanced, astronomers were able to observe the Milky Way in new wavelengths of light, revealing hidden features that had previously been invisible. For example, radio waves allowed astronomers to map the distribution of hydrogen gas in the galaxy, which was crucial for understanding its spiral structure. In the 1950s and 1960s, new theories emerged regarding the formation and evolution of galaxies. The discovery of the cosmic microwave background radiation in the 1960s provided strong evidence for the Big Bang theory, which posited that the universe had begun in a hot, dense state and had been expanding ever since. This theory not only reshaped our understanding of the universe's origins, but it also forced astronomers to rethink the formation of galaxies, including our own Milky Way. By the 1970s, astronomers had begun to piece together a more accurate model of the Milky Way's structure, thanks in large part to new data from space-based telescopes and improved observations of distant stars and nebulae. It was during this time that the discovery of the supermassive black hole at the center of the Milky Way, Sagittarius A, was made. This discovery, which would later become a key part of our understanding of galactic formation and behavior, added a new layer of complexity to our view of the galaxy. The modern era, breaking new ground. In recent decades, advances in technology have propelled our understanding of the Milky Way to new heights. The launch of space telescopes such as the Hubble Space Telescope and the more recent James Webb Space Telescope has allowed astronomers to observe the galaxy in unprecedented detail, capturing images of distant stars, nebulae, and even exoplanets. The discovery of gravitational waves and the development of new technologies for studying the cosmos have opened new avenues for research, allowing us to probe the galaxy in ways that were once unimaginable. The recent discovery of an anomaly within the Milky Way, as mentioned earlier, is just the latest in a long line of surprising revelations about our galaxy. With each new discovery, we are forced to confront the fact that the Milky Way and the universe at large are far more complex than we could have ever imagined. And yet, for all that we have learned, there is still so much left to uncover. Conclusion. The journey continues. The history of galactic discoveries is a testament to the power of human curiosity and the incredible advances in science and technology that have shaped our understanding of the Milky Way. From the early observations of ancient astronomers to the groundbreaking discoveries of modern space science, each step has brought us closer to understanding the true nature of our galaxy. But even as we celebrate our progress, we must remember that the Milky Way remains a vast, mysterious frontier, full of secrets yet to be discovered. The journey of exploration continues, and with each new breakthrough, we move ever closer to understanding the galaxy we call home. In the vast expanse of the Milky Way, where stars, planets, and nebulae swirl through space, a new discovery has rocked the world of astronomy. For years, we have gazed into the depths of our galaxy, using the best tools and most sophisticated technology to uncover its secrets. Yet, nothing could have prepared scientists for the unexpected revelation they recently encountered, a discovery so stunning that it has the potential to change the way we think about our galaxy, and possibly even the fundamental laws of physics. What exactly did scientists find, and why is this discovery being hailed as a groundbreaking moment in the history of astronomy? The answer lies in a phenomenon that, until now, had never been observed in the Milky Way, challenging our understanding of the very forces that govern the universe. The search for anomalies. Astronomers have long been aware that space is full of mysteries, from the behavior of dark matter to the strange properties of black holes. But what makes this particular discovery so extraordinary is the fact that it was completely unexpected. It all began with a routine observation, a deep scan of a region of the Milky Way that had previously been overlooked. Using advanced instruments such as the powerful radio telescopes and gravitational wave detectors that have become the backbone of modern astronomical research, scientists aimed to explore an area of the galaxy that was thought to be relatively unremarkable. The idea was to gather more data on the usual phenomena: stars, gas clouds, and the movement of celestial bodies. But what they discovered wasn't just another star or nebula, it was an anomaly, an unexpected disturbance in the fabric of space itself. This disturbance, however, was unlike any that had been observed before. It wasn't a simple irregularity in the motion of a distant star or an unusual radiation signal. It was something far more perplexing, something that didn't align with the known laws of physics, and that suggested the existence of a previously unknown force at play within our galaxy. As the data flooded in, it became clear that this anomaly was no fluke. The disturbance was not just an isolated event, it was a pattern. A series of subtle yet undeniable signals began to emerge from multiple sources within the region being observed, each one suggesting a gravitational anomaly that defied the expectations of scientists. This anomaly, though subtle, had the power to disrupt the typical gravitational balance within that part of the Milky Way. The question on everyone's mind was, what could be causing this disruption, and how could something like this exist without being detected earlier? The detection of gravitational waves. The breakthrough came when researchers realized that the disturbance they had detected was likely related to gravitational waves, ripples in space-time caused by massive objects accelerating through space. Gravitational waves were first predicted by Albert Einstein in his general theory of relativity, but it wasn't until 2015 that the Laser Interferometer Gravitational Wave Observatory, LIGO, made the first direct detection of these waves. Since then, scientists have been refining their ability to detect and study these elusive signals, which carry information about the most extreme events in the universe, such as colliding black holes or supernovae. What made this discovery so extraordinary was the fact that it wasn't the result of a cataclysmic event like the collision of black holes or the collapse of a massive star. It was something far subtler, something that hinted at an ongoing, invisible force at work within the galaxy. The gravitational waves detected from this anomaly were not the result of a single event, but rather a continuous disturbance that seemed to be emanating from multiple points in space. This suggested that the source of the anomaly might not be a single event, but rather a persistent underlying force affecting a larger portion of the galaxy. Unraveling the mystery. Theories and hypotheses. As scientists scrambled to understand the implications of this discovery, several theories began to emerge. Some suggested that the disturbance might be related to the behavior of dark matter, a mysterious, invisible substance that makes up much of the mass in the universe, but has so far eluded direct detection. Dark matter is thought to interact with regular matter only through gravity, and its presence is inferred from its gravitational effects on visible matter. If this anomaly were connected to dark matter, it would represent a significant breakthrough in understanding this elusive substance. Others speculated that the disturbance could be related to a previously unknown type of cosmic object, one that doesn't fit into the categories of stars, black holes, or neutron stars. Could there be a new type of object lurking in the depths of space, one that produces gravitational waves without emitting visible light or other detectable radiation? Such an object would be difficult to detect with traditional methods, but the presence of gravitational waves could offer a key to unlocking its nature. The most intriguing theory, however, was that this discovery might point to a new and unknown force, something that operates beyond the realms of conventional gravity and electromagnetism. This could be a force that interacts with space-time in ways we don't yet fully understand. If true, this would have profound implications for our understanding of the universe, potentially rewriting the laws of physics and offering insights into the very nature of space, time, and the fundamental forces of the cosmos. The role of technology in the discovery. What makes this discovery even more impressive is the technology that made it possible. In the past, astronomers relied on optical telescopes that could only observe visible light. While these instruments have provided incredible insights into the nature of stars, planets, and galaxies, they are limited in their ability to detect phenomena like gravitational waves. The advent of radio telescopes, space-based observatories, and advanced detection methods has opened up entirely new avenues for exploration. In the case of this discovery, astronomers used a combination of gravitational wave detectors, radio telescopes, and cutting-edge software to analyze the data and pinpoint the source of the anomaly. These technologies allowed scientists to detect tiny ripples in space-time, analyze the frequency and amplitude of the signals, and model their origins. By combining these observations with existing data from other sources, such as X-ray and infrared observations, researchers were able to conclude that the anomaly was real and not just a false positive. One of the key instruments involved in the discovery was the recently upgraded Very Large Telescope, VLT array in Chile, which provided astronomers with high-resolution images of the region where the anomaly was detected. These images revealed a previously unseen structure in space, a vast gravitationally influenced area that was unlike anything ever observed in the Milky Way. The wider implications. The immediate reaction to this discovery was one of astonishment. The implications for astronomy, physics, and cosmology are immense. If the anomaly is related to dark matter, it could offer the first direct evidence of its existence, something that has eluded scientists for decades. Dark matter is one of the biggest unsolved mysteries in modern science, and proving its existence would be a monumental achievement in our understanding of the universe. If the disturbance is caused by a new cosmic object, it could signal the discovery of an entirely new class of celestial body, one that doesn't emit light yet has a powerful gravitational effect on its surroundings. This could lead to a new wave of research into the nature of these objects and their role in the formation and evolution of galaxies. And if the anomaly is indeed the result of a previously unknown force interacting with space-time itself, it could redefine our understanding of the fundamental forces that govern the universe. Such a discovery would force physicists to reconsider the foundations of modern physics, potentially leading to the development of new theories that integrate this new force with our current understanding of gravity and quantum mechanics. The future of galactic exploration. The discovery of this gravitational anomaly is not the end of the story. It's just the beginning. As astronomers continue to analyze the data and refine their models, it's likely that more answers will emerge. Future space missions, such as the James Webb Space Telescope, will provide even more detailed observations of the region where the anomaly was detected. New technologies and methods of detection will likely uncover even more hidden phenomena within the Milky Way, leading to further breakthroughs in our understanding of the galaxy. This discovery serves as a reminder of how much we still don't know about the Milky Way. Despite all of our advances, our galaxy is still full of mysteries waiting to be uncovered. As we continue to peer into the darkness of space, we are bound to find more surprises, each one more fascinating and thought-provoking than the last. The stunning discovery made within the Milky Way has left scientists and astronomers around the world scrambling to understand its implications. As groundbreaking as it is, this revelation has also introduced more questions than answers, prompting researchers to develop a number of hypotheses and theories to explain the phenomenon. What does it mean for the structure of our galaxy, and what could it tell us about the fundamental forces that shape the universe? In this chapter, we will explore some of the key theories that have emerged in response to the discovery, delving into the potential implications for our understanding of astrophysics, the nature of gravity, and the very fabric of space-time itself. The role of dark matter. One of the most intriguing hypotheses surrounding this discovery is the possibility that the anomaly is related to dark matter. Dark matter, which makes up about 85% of the universe's mass, is one of the biggest mysteries in modern science. While we can't see it directly, its existence has been inferred from its gravitational effects on visible matter, such as stars and galaxies. Dark matter does not emit or absorb light, making it invisible to traditional telescopes, and it doesn't interact with ordinary matter in any way that we can easily detect. Yet, scientists have long believed that it plays a crucial role in the formation and behavior of galaxies, including the Milky Way. If this anomaly is connected to dark matter, it could represent the first direct evidence of this elusive substance. The disturbance observed by astronomers could be the result of dark matter interacting with the normal matter in our galaxy in ways we hadn't previously understood. This would be a monumental discovery in itself, as it would offer us a much-needed glimpse into the properties of dark matter, something that has remained hidden for so long. The idea of dark matter causing the anomaly is particularly compelling because it could help explain some of the gravitational effects observed in the Milky Way. Scientists have long known that the outer regions of galaxies, including the Milky Way, rotate much faster than expected based on the visible matter present. This has been a key piece of evidence for the existence of dark matter, as the additional mass it provides would account for the extra gravitational pull needed to explain these rotation curves. However, even though dark matter is the most widely discussed theory, it doesn't provide a complete explanation of the discovery. The anomaly observed in the Milky Way doesn't behave in exactly the way scientists would expect dark matter to interact with regular matter. Dark matter is thought to be spread out in a nearly uniform way throughout the galaxy, yet the disturbance detected by astronomers seems to originate from a more localized area. This has led some researchers to consider alternative theories. A new class of cosmic objects. Another hypothesis gaining traction is the possibility that the anomaly could be the result of a previously unknown class of cosmic objects. These objects would not fit into the categories of stars, black holes, or neutron stars that we're familiar with. They might not emit visible light or other forms of electromagnetic radiation, making them difficult to detect with traditional telescopes. Instead, they might produce gravitational effects without leaving any visible trace. These hypothetical objects could be similar to what is known as dark stars or black dwarfs, which are theoretical stellar remnants that do not shine brightly like regular stars. These objects might have extremely dense cores that create gravitational disturbances, but without emitting the light that we would typically associate with a stellar object. If this hypothesis holds, the anomaly in the Milky Way could point to a completely new class of objects that we have never seen before. Objects that interact with space-time in ways that challenge our current understanding of astrophysics. One possibility is that the anomaly could be caused by a massive, invisible object that is exerting a powerful gravitational influence on its surroundings. This could be a type of primordial black hole, one that formed during the early stages of the universe, but is not massive enough to be detected through the typical methods used to observe black holes. Primordial black holes are a speculative concept, but they are thought to have formed from fluctuations in the density of matter shortly after the Big Bang. If these objects exist, they could account for the gravitational disturbances observed in the Milky Way. Other possibilities include supermassive objects that exist in a different form than what we typically think of as black holes. These objects could have properties that are vastly different from traditional stars or black holes, and might not be detectable through the usual methods of electromagnetic observation. Instead, their gravitational influence could be the only detectable signature of their existence, making them invisible to traditional telescopes, but detectable through their gravitational effects. A new gravitational force. While dark matter and unseen cosmic objects are the most popular theories, another possibility that has been proposed is the existence of a new, unknown force in the universe. The disturbance detected in the Milky Way could be a manifestation of a force that operates outside the realms of our current understanding of physics. This hypothesis suggests that the force responsible for the anomaly might interact with space-time in a completely novel way, one that does not conform to the established laws of gravity and electromagnetism. If this hypothesis is correct, it would represent a monumental shift in our understanding of the universe. The discovery of a new force would force scientists to reconsider the fundamental laws of physics, including our understanding of gravity. For centuries, gravity has been described by Isaac Newton's laws and later refined by Albert Einstein's theory of general relativity. According to these theories, gravity is a force that warps space-time and causes objects to move toward each other. But what if there is another force at work, one that operates in a way we have not yet fully comprehended? This new force might not operate in the same way that gravity does. Instead of simply attracting objects to one another, it could create disturbances in space-time that we haven't observed before. It might be capable of affecting the motion of stars and galaxies without producing the typical electromagnetic signals we associate with other forces. If such a force exists, it could open up an entirely new field of study, one that challenges everything we know about the forces that govern the universe. Some scientists have proposed that this force could be related to the concept of extra dimensions in space. Theories such as string theory suggest that the universe may have more than the 3 dimensions of space and one of time that we experience in our daily lives. If extra dimensions exist, they could be responsible for creating new forces or interactions that are not detectable in our conventional understanding of the universe. The anomaly in the Milky Way might be the first hint of such extra-dimensional forces at work. The implications for our understanding of the Milky Way. Regardless of the exact cause of the anomaly, the discovery itself has far-reaching implications for our understanding of the Milky Way and the universe as a whole. If this disturbance is related to dark matter, it could help us understand the role that dark matter plays in the formation and evolution of galaxies. It could provide us with the first direct evidence of dark matter's existence, something that has eluded scientists for decades. If the anomaly is caused by an unknown cosmic object or force, it would suggest that our galaxy is even more complex and mysterious than we could have ever imagined. The discovery would point to new phenomena, new types of objects, and potentially new laws of physics that have yet to be explored. The implications extend beyond just the Milky Way. If the anomaly is connected to a new force or class of objects, it could force scientists to rethink the structure of other galaxies and the processes that govern their formation. It might even have implications for our understanding of the larger universe, potentially offering clues about the origins of galaxies, the behavior of dark matter, and the nature of space-time itself. The path forward. As scientists continue to investigate this anomaly, it is clear that the discovery is just the beginning. Further research will be necessary to fully understand the nature of the disturbance and its implications for our understanding of the Milky Way and the universe. With the help of advanced telescopes, space missions, and computational models, astronomers will be able to refine their theories and gather more data, bringing us closer to unlocking the secrets of this remarkable discovery. In the meantime, the scientific community remains in a state of eager anticipation, awaiting the answers that will emerge from this groundbreaking find. What we do know is this: the Milky Way is a far more complex and mysterious place than we ever imagined, and this discovery is just the first step in a much larger journey of exploration and discovery. As with every groundbreaking discovery, the science behind the recent anomaly detected in the Milky Way is complex, multifaceted, and requires a thorough understanding of the tools, theories, and principles that led to its identification. To fully appreciate the significance of this discovery, we must dive deeper into the scientific methods and technologies that made it possible, explore the principles behind the phenomenon, and understand how researchers were able to detect something so elusive in the vastness of space. The role of gravitational waves. At the heart of this discovery lies the detection of gravitational waves, ripples in space-time caused by the acceleration of massive objects. Gravitational waves were first predicted by Albert Einstein in 1915 as part of his theory of general relativity, which describes how gravity operates not just as a force between objects, but as a warping of the fabric of space and time itself. According to Einstein's equations, massive objects like stars, black holes, and even entire galaxies cause a distortion in the space-time continuum as they move. These distortions propagate outward in the form of gravitational waves, much like ripples spreading across a pond when a stone is dropped. Einstein's theory suggested that these waves travel at the speed of light, carrying information about the objects that cause them. However, for almost a century, these waves remained purely theoretical, as the technology required to detect them was far beyond what was available. It wasn't until 2015 that researchers at the Laser Interferometer Gravitational Wave Observatory, LIGO, made the first direct detection of gravitational waves. This discovery was one of the most significant scientific achievements of the 21st century, confirming Einstein's predictions and opening up a whole new field of astronomy. Gravitational waves provide astronomers with a unique way of observing the universe. Unlike traditional telescopes, which rely on visible light, radio waves, or X-rays to capture images of celestial objects, gravitational waves offer a direct glimpse into the most violent and energetic events in the universe. These waves can be produced by the collision of black holes, the explosion of supernovae, or even the motion of massive stars. In the case of the recent discovery in the Milky Way, gravitational waves were key to detecting a subtle but powerful disturbance that had never been observed before. The detection of gravitational waves from this anomaly was not straightforward. The waves were faint, their signal buried beneath the background noise of the galaxy. However, by using advanced data analysis techniques and highly sensitive equipment, astronomers were able to isolate the signals from the background and confirm that they were coming from a previously unknown source. This marked a major milestone in the study of gravitational waves and demonstrated the power of this technology in uncovering hidden phenomena. The technology behind the discovery. To detect gravitational waves, scientists use a highly specialized tool known as an interferometer. LIGO, one of the most advanced gravitational wave observatories, consists of two massive laser interferometers located in Louisiana and Washington state. These detectors are capable of measuring incredibly tiny changes in the distance between mirrors placed kilometers apart, changes on the order of a fraction of the width of a proton. When a gravitational wave passes through Earth, it causes a slight stretching and squeezing of space-time, altering the distance between the mirrors. By measuring these changes with extreme precision, scientists are able to detect the passing waves. LIGO's interferometers use two perpendicular arms, each several kilometers long, and powerful lasers that travel down these arms. When a gravitational wave passes through the detectors, it causes the space-time to distort, stretching one arm and compressing the other. The lasers, which bounce back and forth between mirrors at the ends of each arm, can detect these minuscule shifts in distance, allowing the observatory to hear the waves. However, gravitational waves are not the only form of observation used to detect cosmic phenomena. In this case, the recent discovery in the Milky Way was made possible through a combination of radio telescopes, space-based observatories, and high-powered data processing techniques. Instruments such as the Very Large Array, VLA, in New Mexico and the recently launched James Webb Space Telescope, JWST, played key roles in identifying the source of the anomaly. Radio telescopes, which detect electromagnetic radiation at low frequencies, provided astronomers with detailed maps of the galaxy. These telescopes allow scientists to observe regions of space that are otherwise invisible to the naked eye or optical telescopes. By studying the radio emissions from the region where the anomaly was detected, astronomers were able to pinpoint its location and begin investigating its cause. The JWST, set to revolutionize the field of astronomy with its unprecedented ability to observe the universe in the infrared spectrum, has also been an invaluable tool for this discovery. The infrared capabilities of JWST allow it to peer into the dust clouds that often obscure our view of certain regions of space, revealing hidden stars, black holes, and nebulae that might otherwise remain unseen. Combining data from these various observatories, astronomers were able to form a more complete picture of the Milky Way and the hidden anomaly within it. This multi-instrument approach is becoming increasingly common in modern astronomy, where no single tool can provide all the answers, but a combination of observations and analyses can lead to breakthrough discoveries. Theoretical models and simulations. The detection of the gravitational anomaly in the Milky Way is not just a feat of technological prowess. It also required the application of advanced theoretical models and simulations. For scientists to interpret the gravitational waves and understand the physical processes behind them, they had to rely on decades of work in theoretical physics, particularly in the fields of general relativity and astrophysics. General relativity, Einstein's theory of gravity, is the cornerstone of our understanding of spacetime. According to general relativity, mass and energy warp the fabric of spacetime, creating the force we perceive as gravity. This warping is what causes planets to orbit stars and stars to orbit the centers of galaxies. The theory also predicts that large-scale gravitational events, such as the collision of black holes or the collapse of massive stars, can send ripples through spacetime in the form of gravitational waves. Simulations based on general relativity allow scientists to model these events and predict how gravitational waves would behave when detected by instruments like LIGO. By running these simulations, astronomers were able to compare the observed data with theoretical models and determine the most likely causes of the anomaly. The fact that the gravitational waves detected in this case did not match any previously known cosmic events led scientists to propose new models of galactic behavior, models that might include new forms of matter, energy, or even previously unknown forces. The anomaly's potential link to black holes. One of the leading theories surrounding the anomaly is that it might be related to black holes. These mysterious cosmic objects are known for their intense gravitational pull, which is so strong that not even light can escape from them. Black holes are typically formed when massive stars collapse under their own gravity, creating a singularity, a point in space where matter is compressed to an infinitely small size, creating an intense gravitational field. The recent discovery in the Milky Way could be related to the movement of smaller, intermediate black holes that are thought to exist in the galaxy. These black holes are not as massive as the supermassive black hole at the center of the Milky Way, but they could still produce powerful gravitational waves if they interact with other objects, such as stars or gas clouds. Researchers are also investigating the possibility that the disturbance is related to the accretion disks around black holes. These disks, made up of gas and dust, swirl around the black hole at incredibly high speeds, generating immense gravitational forces. The interaction between the black hole and its accretion disk could create gravitational waves that ripple through spacetime. If this is the case, it would be a breakthrough in our understanding of black hole dynamics and their role in shaping the galaxy. Beyond black holes, new theories in physics. While the black hole theory is one of the leading explanations, there are other possibilities that could explain the anomaly. Some scientists are considering the idea that the disturbance might be linked to a new, previously unknown force or particle that interacts with gravity in unusual ways. This could lead to new discoveries in particle physics and our understanding of fundamental forces. If this hypothesis proves true, it could have profound implications for our understanding of spacetime, gravity, and the nature of the universe. In the coming years, astronomers will continue to investigate the anomaly, refining their models and theories as they gather more data. Whether it's dark matter, black holes, or a new force in physics, this discovery has the potential to reshape our understanding of the Milky Way and the universe at large. The future of galactic exploration. The breakthrough discovery in the Milky Way represents just the tip of the iceberg in our exploration of the galaxy. With new technologies, such as the upcoming Square Kilometre Array, SKA, which will allow scientists to observe the universe in unprecedented detail, and the continued refinement of gravitational wave detectors, the future of galactic exploration looks incredibly promising. As we continue to peer deeper into the Milky Way, we can expect more discoveries that challenge our current models and offer new insights into the forces that shape the cosmos. This discovery has reaffirmed the excitement of space exploration. For every question answered, there are countless more to ask. The Milky Way remains a vast, mysterious frontier, and with each new breakthrough, we uncover just a little bit more about the incredible universe we call home. To truly appreciate the magnitude of the recent discovery within the Milky Way, it is essential to understand the methods and technologies that allow scientists to study such a vast and mysterious galaxy. The Milky Way is an intricate and dynamic system, and exploring it is no small task. Over the past few decades, astronomers have developed increasingly sophisticated tools to peer deeper into the galaxy and uncover its hidden secrets. From traditional telescopes to the latest space-based observatories, the study of the Milky Way is an ever-evolving field, one that continues to push the boundaries of our knowledge and technology. In this chapter, we'll explore the cutting-edge technologies and techniques that scientists use to study the Milky Way, how they overcome the immense challenges posed by such an enormous galaxy, and what the future holds for galactic exploration. Telescopes, the eyes of astronomers. The most fundamental tool in the study of the Milky Way has always been the telescope. For centuries, astronomers have used telescopes to observe distant stars, planets, and other celestial objects. Early telescopes, such as the ones used by Galileo in the 17th century, allowed scientists to peer deeper into space than ever before. These early observations led to the first understanding of the Milky Way as a collection of individual stars rather than a mysterious band of light. In the modern era, telescopes have evolved exponentially. The development of more advanced optical telescopes, such as the Hubble Space Telescope, has given astronomers unprecedented views of our galaxy. The Hubble Space Telescope, launched in 1990, has allowed scientists to capture images of distant stars, nebulae, and other objects in the Milky Way with incredible clarity. By observing the galaxy in visible light, astronomers have been able to map out the structure of the Milky Way, including its spiral arms, central bulge, and halo of stars and dark matter. Despite the advances in optical telescopes, they are limited in the types of information they can provide. Many of the most intriguing phenomena in the galaxy, such as dark matter, black holes, and the formation of stars, are invisible to optical telescopes. For this reason, astronomers have turned to other wavelengths of light to study the galaxy. Radio telescopes, seeing the invisible. While optical telescopes capture visible light, radio telescopes observe radio waves, which are a form of electromagnetic radiation that is invisible to the naked eye. Radio waves can travel through dense clouds of gas and dust, making them invaluable for studying regions of the galaxy that are otherwise obscured. In fact, many of the most important discoveries about the Milky Way have been made using radio telescopes. The Very Large Array, VLA, in New Mexico, USA, is one of the most well-known and powerful radio observatories in the world. The VLA consists of 27 radio antennas spread out over a 36-kilometer area, allowing it to capture high-resolution images of the galaxy in radio wavelengths. The VLA has been used to study everything from the formation of stars and the behavior of black holes to the distribution of dark matter in the galaxy. One of the most significant contributions of radio telescopes to our understanding of the Milky Way has been their ability to detect the faint signals emitted by hydrogen gas. Hydrogen is the most abundant element in the universe, and its presence in the galaxy can be detected through its radio emissions. By studying the distribution of hydrogen in the Milky Way, astronomers have been able to map the galaxy's spiral arms and gain insights into the processes of star formation and galactic dynamics. Radio waves are also used to detect and study other phenomena, such as pulsars, quasars, and cosmic microwave background radiation. Pulsars, which are rapidly rotating neutron stars, emit regular pulses of radio waves that can be detected from Earth. By studying these pulses, astronomers can learn about the extreme conditions around neutron stars and the behavior of matter in these incredibly dense objects. X-ray and infrared observatories, peering beyond the visible. While radio telescopes are excellent for observing certain phenomena, they are not sufficient for studying all aspects of the Milky Way. Some of the most fascinating objects in the galaxy, such as black holes, neutron stars, and star-forming regions, emit radiation in wavelengths that are outside the range of optical and radio telescopes. To study these objects, astronomers turn to space-based observatories that are capable of detecting X-rays and infrared radiation. X-ray telescopes, such as the Chandra X-ray Observatory, launched in 1999, have provided unprecedented views of high-energy events in the galaxy. X-rays are produced by extremely hot and energetic processes, such as the accretion of gas into black holes and the explosive deaths of massive stars. By observing the X-ray emissions from these objects, scientists can learn about the behavior of matter under extreme conditions, such as the intense gravitational forces near black holes or the temperatures found in supernova remnants. Infrared telescopes, like the Spitzer Space Telescope, launched in 2003, are similarly important for studying the Milky Way. Infrared radiation is emitted by cooler objects that might not be visible in optical wavelengths, such as dust clouds, brown dwarfs, and newly forming stars. The Milky Way is full of regions where new stars are being born, and infrared telescopes are essential for peering into these regions to observe the birth of stars and planetary systems. By studying the infrared radiation emitted by these objects, astronomers can better understand the processes that govern star formation and the evolution of galaxies. The infrared observations made by these telescopes have also provided insights into the distribution of dust in the galaxy. Dust plays a crucial role in the formation of stars and planets, and studying its distribution can provide valuable clues about the structure and evolution of the Milky Way. Gravitational wave detection. The new frontier. In recent years, one of the most exciting developments in the study of the Milky Way has been the detection of gravitational waves. These ripples in space-time, first predicted by Albert Einstein over a century ago, were directly observed for the first time in 2015 by the Laser Interferometer Gravitational Wave Observatory, LIGO. Gravitational waves are produced by the acceleration of massive objects, such as the collision of black holes or the collapse of supernovae. These waves carry information about the most extreme events in the universe, and their detection has opened up a whole new way of observing the cosmos. Gravitational waves are unique in that they can travel through space without being affected by intervening matter, unlike light, which can be absorbed or scattered by dust and gas. This makes gravitational waves an invaluable tool for studying hidden phenomena in the Milky Way, such as the interactions of black holes or the movements of dense stellar remnants. The recent discovery of an anomaly in the galaxy, potentially linked to gravitational waves, highlights the importance of this new observational tool in unraveling the mysteries of the Milky Way. LIGO and other gravitational wave detectors are still in the early stages of their operation, and scientists are only beginning to scratch the surface of what gravitational waves can reveal about the Milky Way and the universe. As the technology improves and more detectors come online, the ability to observe gravitational waves will only increase, offering even more insights into the most energetic and extreme events in the galaxy. The role of computational models and simulations. In addition to the tools used to observe the Milky Way directly, computational models and simulations play a crucial role in the study of our galaxy. The vastness of the Milky Way, combined with the complexity of the forces at work within it, makes it difficult to study through observation alone. To make sense of the data gathered by telescopes, astronomers use sophisticated computational models that simulate the behavior of galaxies, stars, and other cosmic phenomena. These models allow scientists to explore different scenarios and test hypotheses about how the galaxy works. For example, simulations of star formation help astronomers understand how clouds of gas and dust collapse to form new stars. Simulations of galactic dynamics help researchers study the motion of stars within the galaxy and the effects of gravity on the structure of the Milky Way. Computational models are also used to simulate the behavior of black holes, dark matter, and other elusive phenomena that cannot be directly observed. By comparing the results of these simulations with real-world data, astronomers can refine their theories and gain a better understanding of the processes that shape the Milky Way. In many cases, these simulations provide a crucial link between theory and observation, allowing scientists to test their ideas and make predictions about what might be discovered in the future. The future of galactic exploration. The study of the Milky Way is an ongoing endeavor, one that will continue to evolve as new technologies and techniques become available. The next generation of telescopes, such as the upcoming Square Kilometre Array, SKA, will provide astronomers with even more detailed views of the galaxy, allowing them to study everything from the behavior of dark matter to the structure of distant star-forming regions. The James Webb Space Telescope, set to launch in the coming years, will also provide unparalleled views of the Milky Way in the infrared, allowing scientists to peer deeper into the galaxy and uncover hidden secrets. As technology continues to advance, our ability to observe the Milky Way and understand its complexities will only grow. But even with all these new tools and technologies, one thing is clear. There is still so much we don't know. The Milky Way is a vast and dynamic system, and each new discovery brings with it more questions than answers. As we continue to explore its depths, we will undoubtedly uncover even more surprising and fascinating phenomena, pushing the boundaries of our understanding of the universe. The recent discovery within the Milky Way has ignited a new wave of excitement and curiosity in the scientific community, signaling the dawn of a new era in galactic research. As astronomers and physicists continue to study the anomaly and its potential implications, they are also looking ahead to the future of space exploration. The tools, technologies, and methods of research that are currently at our disposal have already yielded remarkable results, but they represent only a fraction of what is possible. As we continue to push the boundaries of our understanding of the Milky Way, we are on the cusp of new discoveries that could change the way we see the galaxy and the universe forever. In this chapter, we'll explore the future of galactic research, the technological advancements that will drive new discoveries, and the missions that will lead us to a deeper understanding of the Milky Way's secrets. From next-generation space telescopes to groundbreaking space missions, the future of galactic exploration is brimming with potential. The role of next-generation space telescopes. One of the most exciting developments in the field of space exploration is the launch of next-generation space telescopes. These advanced observatories will allow scientists to observe the universe in unprecedented detail and across a wide range of wavelengths. These telescopes are poised to play a critical role in the continued study of the Milky Way and its many mysteries. The James Webb Space Telescope, JWST, set to launch in late 2021, is one of the most anticipated telescopes in history. Built to observe the universe in the infrared spectrum, the JWST will be able to peer through cosmic dust clouds that obscure the view of distant stars and galaxies. This ability to look into previously hidden regions of space will provide astronomers with a wealth of new information about the Milky Way, including insights into star formation, planetary systems, and the behavior of supermassive black holes at the center of galaxies. One of the primary goals of JWST is to study the formation and evolution of galaxies. By observing the Milky Way and its neighboring galaxies in infrared wavelengths, the telescope will provide a clearer picture of how galaxies like our own were formed and how they have evolved over billions of years. This information will be crucial in understanding the recent discovery of the anomaly in the Milky Way, as well as the broader processes that govern the dynamics of galaxies. In addition to JWST, the Nancy Grace Roman Space Telescope, formerly known as WFIRST, will be another vital tool for the study of the Milky Way. Set to launch in the mid-2020s, this telescope will be equipped with a wide-field infrared camera, allowing it to capture large portions of the sky at once. Roman's mission will focus on understanding dark energy, the mysterious force that is driving the accelerated expansion of the universe, and dark matter, which remains one of the greatest unknowns in astrophysics. Both of these telescopes will provide new insights into the structure and behavior of galaxies, including the Milky Way. By studying the distribution of dark matter, the process of star formation, and the movement of stars within the galaxy, astronomers will be able to refine their models and gain a deeper understanding of the forces at work within our galaxy. Space missions, expanding our reach. While space telescopes are invaluable for observing distant regions of the galaxy, direct exploration of the Milky Way and beyond requires space missions capable of traveling to the far reaches of our cosmic neighborhood. These missions are critical for collecting data on the objects and phenomena that lie beyond the reach of telescopes and for testing hypotheses that cannot be answered by observation alone. One such mission is ESA's Gaia Space Observatory, launched by the European Space Agency in 2013. Gaia's mission is to map the positions, velocities, and distances of over 1 billion stars in the Milky Way, providing the most detailed and comprehensive 3D map of our galaxy ever created. By measuring the positions and motions of stars with unprecedented precision, Gaia will help astronomers study the structure and dynamics of the Milky Way, shedding light on the distribution of dark matter, the movement of stars, and the history of our galaxy. Gaia's data will also be crucial for understanding the recent discovery in the Milky Way. The high-precision measurements provided by the spacecraft will allow scientists to pinpoint the exact location of the anomaly and study how it fits into the larger galactic structure. With Gaia's data, astronomers will be able to test various hypotheses about the source of the disturbance, such as the presence of dark matter or an unknown gravitational force, and refine their models of galactic behavior. Beyond Gaia, other missions are also on the horizon, each with its own set of goals and objectives. The Lucy mission, launched by NASA in 2021, will travel to the Trojan asteroids, which orbit the Sun in the same path as Jupiter. By studying these ancient space rocks, Lucy will provide valuable insights into the early history of the solar system, but it will also help astronomers refine their understanding of the Milky Way's formation. The mission will provide new data on the distribution of water, organic compounds, and other materials in our galaxy, which are essential for understanding the conditions that led to the formation of life. The search for exoplanets. Understanding the broader picture. One of the most exciting areas of research in the Milky Way is the search for exoplanets, planets that orbit stars outside our solar system. Over the past few decades, astronomers have discovered thousands of exoplanets, some of which are located in the habitable zone of their parent stars, where liquid water could exist. The discovery of potentially habitable exoplanets has profound implications for our understanding of the galaxy and the possibility of life beyond Earth. Space telescopes like Kepler and TESS, Transiting Exoplanet Survey Satellite, have revolutionized the search for exoplanets by providing astronomers with the tools to detect planets orbiting distant stars. Kepler, which operated from 2009 to 2018, discovered more than 2,600 confirmed exoplanets, while TESS, launched in 2018, has been on a mission to map the entire sky for exoplanets. These telescopes work by detecting the subtle dimming of a star's light as a planet passes in front of it. This method, known as the transit method, has proven to be one of the most effective ways of detecting exoplanets, particularly those that are Earth-like in size and temperature. By studying these planets, astronomers can learn more about the conditions that make life possible and how common Earth-like planets might be in the Milky Way. The discovery of exoplanets also ties into the study of the Milky Way's structure. By identifying planets in different regions of the galaxy and studying the chemical composition of their atmospheres, scientists can gain insights into the conditions that lead to the formation of planets, stars, and galaxies. This research will provide a broader understanding of the Milky Way's evolution and the processes that shape its stars, planets, and life-supporting environments. The role of computational modeling in galactic research. As our ability to observe the galaxy continues to improve, so too does our ability to simulate and model the behavior of the Milky Way. Computational modeling is a vital tool in modern astrophysics, allowing scientists to test their hypotheses, simulate cosmic events, and predict the outcomes of various scenarios. These models use the laws of physics, such as general relativity and quantum mechanics, to simulate the behavior of stars, galaxies, and even entire cosmic structures. One of the most powerful tools in galactic research is hydrodynamic simulations, which model the behavior of gas, dust, and dark matter in galaxies. These simulations are critical for understanding the formation of galaxies, star formation, and the interaction of dark matter with visible matter. By simulating the conditions in different regions of the Milky Way, astronomers can test their theories about how galaxies evolve, how stars are born and die, and how the presence of dark matter affects the structure of the galaxy. In the wake of the recent discovery in the Milky Way, computational models will be crucial for testing hypotheses about the cause of the anomaly. Whether it's a result of dark matter, a new type of cosmic object, or an entirely unknown force, simulations will help researchers refine their understanding of the galaxy and provide a framework for interpreting new data. The power of computational modeling is that it allows scientists to experiment with different possibilities and test their theories against the data collected by telescopes and space missions. Future technologies. The next frontier. Looking ahead, the future of galactic exploration is incredibly bright. Advances in artificial intelligence, AI, machine learning, and data processing will further enhance our ability to analyze the vast amounts of data generated by space telescopes, observatories, and space missions. AI will play an increasingly important role in identifying patterns in data, detecting anomalies, and automating the analysis of complex data sets, allowing astronomers to make faster discoveries and refine their models with greater precision. In addition, upcoming space missions, such as the Square Kilometre Array, SKA, will provide an unprecedented ability to study the universe in radio wavelengths. The SKA, when completed, will consist of thousands of radio antennas spread across large distances, creating the world's largest and most powerful radio telescope. With its immense sensitivity and resolution, the SKA will revolutionize our understanding of the Milky Way, allowing us to observe the galaxy in incredible detail and study its hidden structures. The next few decades promise to be an exciting time for the study of the Milky Way and the broader universe. As we continue to develop new technologies, improve existing instruments, and launch new missions, our understanding of the galaxy will deepen. The recent discovery of the anomaly in the Milky Way is just the beginning. With each new tool and each new mission, we move closer to unraveling the mysteries of our cosmic home. The discovery within the Milky Way is far more than a singular breakthrough in our understanding of our galaxy. It represents a new chapter in our exploration of the cosmos and offers profound implications for our understanding of the universe at large. As we work to unravel the mystery behind the anomaly, we must also step back and consider how this discovery fits into the broader cosmic landscape. How does it relate to the larger structure of the universe? What can it tell us about the forces that govern the cosmos and our place in it? And, perhaps most significantly, what does it reveal about the nature of space, time, and the fundamental laws that shape everything around us? In this chapter, we will explore how the recent discovery in the Milky Way fits into the grander narrative of the universe. From the formation of galaxies to the behavior of dark matter, we will examine how this anomaly connects to the larger story of cosmic evolution and the mysteries that still await us. We will also consider the philosophical and existential questions raised by this discovery, as it challenges us to rethink our place in the cosmos. The Milky Way's role in the larger universe. The Milky Way is just one of the billions of galaxies that populate the universe, each of which is an intricate system of stars, planets, gas, and dust. While it may seem like a vast and complex structure on its own, the Milky Way is not isolated. It is part of a much larger cosmic web, interconnected with other galaxies by vast expanses of space. Understanding the Milky Way, then, requires looking beyond our galaxy and considering how it fits into the broader universe. Our galaxy is part of a collection of galaxies known as the local group, a small cluster of about 54 galaxies that includes the Milky Way, the Andromeda Galaxy, and the Triangulum Galaxy, among others. The local group itself is part of a larger structure known as the Laniakea supercluster, a vast region of space that contains thousands of galaxies bound together by gravity. This supercluster is just one of many in the observable universe, highlighting the scale of the cosmos and the vastness of space. Despite its relatively small size in the grand scheme of the universe, the Milky Way is a highly dynamic and important galaxy. It has been the focus of astronomers for centuries, and it plays a central role in our understanding of galaxy formation, evolution, and dynamics. However, while the Milky Way is home to billions of stars and potentially billions of planets, it is by no means unique. The discovery within our galaxy is significant not just for what it tells us about the Milky Way itself, but also for what it reveals about the broader processes that govern the formation and behavior of galaxies across the universe. This discovery could shed light on how galaxies interact with one another, how they form and evolve over time, and how cosmic structures are shaped by the forces of gravity and dark matter. Understanding the Milky Way in this context could provide new insights into the formation of galaxies throughout the universe and how they evolve under the influence of unseen forces like dark matter and dark energy. The mystery of dark matter and its role in the universe. One of the most compelling aspects of the recent discovery is its potential connection to dark matter. For decades, astronomers have known that visible matter, stars, planets, and galaxies, makes up only a small fraction of the total mass in the universe. The majority of the universe's mass is thought to be in the form of dark matter, a mysterious substance that does not emit light or interact with electromagnetic radiation in the same way as regular matter. While dark matter remains invisible to us, its presence is inferred from its gravitational effects on visible matter. It is believed to play a crucial role in holding galaxies together, preventing them from flying apart as stars move at incredible speeds through space. Without dark matter, the rotation curves of galaxies, such as the Milky Way, would not make sense. The outer regions of galaxies would rotate much more slowly than they do, as there wouldn't be enough visible mass to hold them together. The recent discovery within the Milky Way could be linked to dark matter in ways we've never seen before. If the anomaly detected by astronomers is indeed connected to dark matter, it would offer the first direct evidence of its existence and potentially provide us with insights into its properties and behavior. This could have far-reaching implications for our understanding of the universe, as dark matter is thought to make up about 85% of the total mass of the cosmos. If we can begin to study dark matter more directly, it could unlock some of the biggest mysteries in physics, including the nature of gravity, the formation of galaxies, and the fate of the universe itself. Dark matter also plays a key role in the larger structure of the universe. It is thought to be responsible for the formation of galaxy clusters and the vast cosmic web that stretches across space. By studying the behavior of dark matter in our own galaxy, we could gain valuable insights into how it shapes the formation and evolution of galaxies throughout the universe. If dark matter is responsible for the anomaly observed in the Milky Way, it could open new doors for understanding its role in the broader cosmic landscape. Dark energy and the expansion of the universe. In addition to dark matter, another key component of the universe is dark energy, a mysterious force that is thought to be responsible for the accelerated expansion of the universe. While dark matter has a gravitational pull that brings matter together, dark energy appears to have the opposite effect, pushing galaxies apart and driving the universe's expansion. The discovery of the anomaly in the Milky Way also raises questions about the role of dark energy in the behavior of our galaxy. Could the disturbance be linked to dark energy in some way, perhaps influencing the motion of stars and galaxies within the Milky Way? The connection between dark energy and dark matter is still poorly understood, and the recent discovery could provide us with valuable clues about how these two enigmatic forces interact. The relationship between dark matter, dark energy, and the overall structure of the universe is one of the most profound unsolved mysteries in modern cosmology. The discovery in the Milky Way may not only help us understand the galaxy's dynamics, but could also provide new insights into the forces that drive the expansion of the universe and the evolution of cosmic structures on the largest scales. The search for life beyond Earth. Perhaps one of the most exciting aspects of the discovery in the Milky Way is its potential implications for the search for life beyond Earth. The anomaly could have far-reaching implications not only for our understanding of the galaxy, but also for our understanding of the conditions necessary for life to exist elsewhere in the universe. If the discovery is linked to dark matter, new cosmic objects, or even unknown forces, it could reveal new regions of space that are rich with potential for the development of life. The Milky Way contains billions of stars, many of which have planets in their habitable zones, regions where conditions are suitable for liquid water to exist on the surface. The discovery of potentially habitable exoplanets has already sparked intense interest in the search for life beyond Earth, and this new anomaly could provide further insights into where life might be found. Could the hidden forces at play in the Milky Way also influence the formation of life in unexpected ways? The anomaly in the Milky Way may not just be a scientific curiosity, it could be a clue to something far more profound. As we continue to study the galaxy, we may discover that life exists in places we never imagined, or that the conditions for life are far more widespread than we ever thought possible. The implications of such a discovery would be nothing short of transformative, altering our view of ourselves and our place in the universe. Philosophical and existential implications. Beyond the scientific implications, the discovery also raises profound philosophical and existential questions. For centuries, humans have looked to the stars with wonder, asking fundamental questions about the nature of the universe, the meaning of life, and our place in the vast cosmic expanse. The recent discovery in the Milky Way forces us to confront the fact that there is still so much we don't know about the universe, and that many of the answers we seek may be waiting to be discovered just beyond our reach. This discovery challenges our perception of the galaxy as a relatively well-understood system, revealing that even in our own cosmic backyard, there are mysteries that remain unsolved. It invites us to consider that the universe may be even stranger and more complex than we could have ever imagined, and it forces us to confront the idea that the search for knowledge is an ongoing journey, one that will continue to unfold over the coming decades and perhaps centuries. As we continue to explore the Milky Way and the universe beyond, we are reminded of the inherent wonder and mystery that lies at the heart of scientific discovery. The questions that have driven humanity's exploration of space for centuries are not just about understanding the physical universe. They are about understanding ourselves and our place in the cosmos. The recent discovery is just another step in this grand adventure, one that promises to reveal even more of the mysteries that lie beyond the stars. Conclusion: the journey continues. The recent discovery within the Milky Way is a remarkable reminder of the vastness and complexity of the universe. It serves as a testament to the power of scientific inquiry, the importance of technological innovation, and the unyielding curiosity that drives our exploration of the cosmos. While the discovery raises more questions than answers, it also opens up new avenues for research, offering the potential to reshape our understanding of the galaxy and the forces that govern it. As we move forward into the future, we can expect even more discoveries that will challenge our perceptions, deepen our understanding, and ultimately bring us closer to unlocking the secrets of the universe. Whether the anomaly is linked to dark matter, a new cosmic object, or an unknown force, the impact of this discovery will resonate throughout the scientific community for years to come. The Milky Way, with all its mysteries and wonders, remains a place of infinite possibilities, one that will continue to captivate our imaginations and fuel our quest for knowledge for generations to come. The discovery that was recently made in the Milky Way has left the scientific community buzzing with excitement and intrigue, offering a tantalizing glimpse into the unknown. For all the knowledge humanity has gained about our galaxy, space continues to surprise us with its vastness, complexity, and hidden mysteries. What we know now is only the beginning of a much larger and deeper journey into the cosmos, a journey that promises to reveal answers to some of the most profound questions about the universe, our galaxy, and our place within it. As we reach the conclusion of our exploration of this discovery, it is clear that the Milky Way is far more intricate and enigmatic than we ever imagined. The recent anomaly detected by scientists in the galaxy is a stark reminder of how little we still understand about the fundamental forces that govern space and time. For every question we answer, new mysteries arise, mysteries that propel us to dig deeper, to question everything, and to reach further into the unknown. The discovery is both an exciting milestone and a humbling realization of the vastness of the universe. It invites us to reflect on the nature of scientific inquiry and the endless pursuit of knowledge. The ever-unfolding quest for understanding. The Milky Way, like all galaxies, is a living, breathing entity, constantly evolving and changing. New stars are born, others die in explosive supernovae, and the dance of gravity continues to shape the galaxy's structure. But while scientists have made incredible strides in mapping the stars, understanding the forces at play, and developing technologies that allow us to explore the farthest reaches of the galaxy, we are still at the beginning of a grand adventure. Every discovery we make in space opens up more questions and challenges our current understanding of the cosmos. The recent breakthrough in the Milky Way is a perfect example of this dynamic process of discovery. The anomaly that was detected by astronomers, whether it's related to dark matter, a new cosmic object, or a previously unknown force, challenges the foundational theories we have about the galaxy and forces us to rethink the rules that govern the universe. While this discovery is groundbreaking in its own right, it also marks the beginning of further investigations that will shape the future of space exploration. As scientists continue to probe the depths of space with increasingly sophisticated instruments, the boundaries of our knowledge will continue to expand. The advent of next-generation telescopes, the continued advancements in gravitational wave detection, and the next wave of space missions all promise to bring us closer to uncovering the mysteries that lie within our own galaxy. These breakthroughs are not just about answering questions. They are about opening up entire new fields of research, revealing cosmic phenomena that were once thought to be beyond our reach. The endless mysteries await. What makes the Milky Way such an exciting and perplexing subject of study is the fact that it is filled with mysteries that are waiting to be uncovered. Our galaxy is a treasure trove of phenomena that continue to challenge our understanding of physics, astronomy, and cosmology. We know that the Milky Way contains billions of stars, and countless exoplanets orbit these stars, many of which might have conditions suitable for life. But beyond these relatively well-understood aspects, there are countless unknowns, whether they be the exact nature of dark matter, the behavior of black holes, the role of dark energy, or the potential existence of new forms of matter and energy. Each discovery we make offers us a new puzzle piece, but it also leaves us wondering about what else is out there. We've already seen how the discovery of gravitational waves, the detection of dark matter, and the observation of distant stars and galaxies have fundamentally altered our view of the universe. The recent anomaly in the Milky Way represents yet another piece of the cosmic puzzle, a clue to something deeper that is still hidden from us. Whether it's a new type of cosmic object, an unknown force of nature, or something entirely unexpected, this discovery is only the beginning of a much larger investigation into the mysteries of space. As astronomers continue to map the galaxy, the answers to the questions we've been asking for centuries are slowly coming into focus, but they will not come all at once. The truth is, the more we learn, the more questions arise. This never-ending cycle of discovery is what makes space exploration so captivating. The pursuit of knowledge about the universe is not a finite task. It's an open-ended journey that will continue for generations to come. The discovery within the Milky Way underscores this truth. It reminds us that space is not something we can conquer or fully comprehend in a single lifetime. It is a realm of infinite complexity and beauty that we will continue to explore as long as we have the curiosity to seek its secrets. The human drive for exploration. At the heart of all of this is the human drive for exploration, the innate desire to understand the world around us and our place within it. Since the dawn of civilization, humans have looked up at the night sky, wondering about the stars, the planets, and the vastness of space. This curiosity has driven us to create powerful telescopes, launch spacecraft, and explore the very fabric of the universe itself. The recent discovery in the Milky Way is a direct result of this drive, a discovery made possible by human ingenuity, perseverance, and the thirst for knowledge. But it is not just the scientific community that benefits from these discoveries. The pursuit of space exploration has far-reaching consequences that extend beyond the realms of astrophysics. It inspires people around the world to look up at the stars and dream. It pushes the boundaries of what is possible, leading to new technologies and innovations that improve life here on Earth. And perhaps most importantly, it fosters a sense of unity and wonder, reminding us all that, despite our differences, we are all part of the same vast interconnected universe. In many ways, the discovery within the Milky Way serves as a symbol of humanity's ability to reach for the stars and unlock the mysteries of the cosmos. It reminds us that the journey of exploration is far from over, that there is still so much to learn, so much to discover, and so much to be amazed by. The universe, with all its complexities, is an ever-unfolding story, one that we are privileged to witness and be a part of. A new era in space research. As we move forward into the future, the implications of this discovery will continue to ripple through the scientific community. The anomaly in the Milky Way is just one piece of a much larger puzzle, and scientists are already planning new research and experiments to explore its cause and implications. Whether the discovery is linked to dark matter, an unknown cosmic object, or a new force in physics, the next few years will see a flurry of research as astronomers and physicists work to answer the questions it has raised. The future of galactic research is brighter than ever. New telescopes, observatories, and space missions are already in the works, each one bringing us closer to understanding the nature of our galaxy and the universe at large. The James Webb Space Telescope, LIGO, Gaia, and other cutting-edge instruments will continue to provide invaluable data as we explore the hidden corners of the Milky Way and beyond. These tools will allow us to study the galaxy in more detail than ever before, providing us with insights into everything from star formation and black holes to the distribution of dark matter and the behavior of distant exoplanets. One of the most exciting developments on the horizon is the upcoming Square Kilometer Array, SKA, a massive radio telescope that will allow scientists to study the Milky Way in unprecedented detail. When completed, the SKA will be able to observe the universe with an unparalleled sensitivity, helping us uncover new phenomena and gain deeper insights into the galaxy's structure and dynamics. The future of galactic exploration is also closely tied to the ongoing search for life beyond Earth. The discovery of potentially habitable exoplanets in our galaxy has already raised profound questions about the existence of life elsewhere in the universe. As we study more of these planets, we will gain a better understanding of the conditions that support life and whether we are truly alone in the cosmos. This search for life, alongside the study of the Milky Way's structure and evolution, will continue to drive space research for decades to come. The infinite frontier. As we conclude this journey through the Milky Way and its most recent discoveries, it becomes clear that the universe is an ever-expanding frontier, one that continues to challenge our understanding and ignite our curiosity. Each new discovery adds another layer to the complex tapestry of the cosmos, and with each answer comes a host of new questions. The recent anomaly detected within the Milky Way is just one of many mysteries that lie hidden within the vast reaches of space, and the quest to uncover those secrets will continue for generations to come. What we've learned from this discovery is not just a scientific breakthrough, it is a reminder of the endless possibilities that await us as we continue to explore the stars. The Milky Way, with all its wonder and complexity, is just one chapter in the story of the universe. And as we venture farther into the unknown, we can be sure that there will be even more mysteries to uncover, more questions to answer, and more awe-inspiring discoveries to be made. The journey of exploration is never truly finished. It is a quest without end, one that will continue to unfold as long as we have the curiosity, the technology, and the imagination to seek out the mysteries of the cosmos.